Look at the foundation of the most profitable media empire in history. Characters like Snow White, Cinderella, and Thor weren't dreamt up in a corporate boardroom. They were ancient, public domain fairy tales and myths, completely free for anyone to use. Walt Disney understood something crucial. His business model relied on taking stories that already had built-in massive audiences and applying animation technology that was so expensive, no competitor could match it. Producing full-color, synchronized sound animation in the 1930s required hundreds of artists, massive studio lots, and thousands of hand-drawn frames. The sheer financial and human capital required created an invisible wall around the industry. For nearly a century, the exclusivity of production technology served as the primary moat protecting media empires. That defensive wall is gone. The decades-old monopoly on high-end animation and cinematic production has completely evaporated. An entire physical studio structure, the ink and paint departments, the Foley stages, the sprawling campus, compresses into a single glowing server rack. We have entered the empire-building phase of artificial intelligence. The exact same playbook used by the biggest studios is now sitting on the desks of solo creators. The modern pipeline starts exactly where the old one did, in the open archive. There is a vast library of over 100 classic intellectual properties, ready to be mined. Cautionary, but there is a strict legal boundary. You must start with the original source material. If you want to adapt Dracula, you pull the original 1897 text, entirely avoiding any modern, trademarked interpretations. Look at this historical 1865 illustration of Alice and the White Rabbit. This is legally safe to use as a visual anchor. A stylized corporate design from a modern theme park is strictly off-limits. Securing a legally clean public domain asset is the mandatory first step. It provides the foundation before a single line of code is executed. Once you have your text, the technological pipeline takes over. A large language model, an AI trained to understand human text, ingests the classic book and breaks the narrative down into discrete, manageable scenes. This diagram illustrates how the system processes the story. It separates raw text into categories, isolating narration, extracting dialogue, and suggesting camera directions. To maintain visual continuity, it generates consistent style sheets and color palettes across every split scene. The software has effectively replaced the human screenwriter and the storyboard artist. It structures raw narrative data perfectly, so the downstream models know exactly what to render. The next step relies on a multimodal prompt. This input combines different types of media, like text, images, and audio, into a single set of instructions for a modern video generation model. Here we see the anatomy of that prompt. It adds a text command to a character reference image and then applies a motion path vector. This mathematical combination dictates exactly how the final video frame should move and look. The machine translates those inputs into a fully realized shot, like this fluid, high-quality pan across a vibrant tea party setting. It maintains the exact aesthetic dictated by the style sheets. Historically, giving a scene like that sound meant putting Foley artists in a room, crashing physical props together in sync with the picture. Today, the same AI models natively mix cloned voice acting and ambient sound directly into the video output. This automated orchestration packages a fully scored cinematic scene into a single machine-readable data manifest. The technical heavy lifting of the assembly line is now handled entirely within the software architecture. The technology is impressive, but the economic reality is what drives the current gold rush. We are looking at a staggering drop in the cost of production friction. This chart compares production costs. The massive historical budget for 1 minute of traditional studio animation collapses into fractions of a dollar when you measure the per-second GPU compute time required by high-fidelity video diffusion models. A diffusion model is an AI that generates detailed images or video by gradually removing noise from a static signal. When you compress those numbers into a total weekly budget, the trend line stabilizes at a threshold so low that a solo creator can run a minimal viable pipeline capable of producing broadcast-quality episodes. Because the financial risk of bringing a cinematic vision to life has dropped to effectively zero, creators are freed from the pressure of box office returns. They can experiment relentlessly. That cheap pipeline triggers a phase of hyper-iteration. Instead of spending years on one concept, you can rapidly test a cyberpunk version of Robin Hood or a sci-fi adaptation of Dracula, watching the audience react in real time. The market will soon be flooded with thousands of distinct iterations, all scrolling upward infinitely. The feedback loop between generation and distribution is nearly instantaneous. The modern media playbook does not require inventing a new mythology from scratch. The goal is to take a story people already love, apply the massive speed of artificial intelligence, and become the definitive version for the next generation.